So we're recording. All right. Hopefully I've not lost my pen. So basically, I'm asking you about Pythagoras' theorem. So what was Pythagoras' theorem? What did I say about? So we know it's about right-angled triangles. But what did Pythagoras and others, which you saw in the video, put down on paper? What did they prove? Oh, that was one of them, wasn't there? Do you remember the 3, 4, 5 triangle? Anyone know what the name of the triangles like the 3, 4, 5 triangle are?
Pythagorean triple.
Pythagorean triple, that's it. It's where all the sides are whole numbers, not the same. Marty. Right, so, but Pythagorean theorem, right? Remember, we've done all this, is all about the squares, isn't it? This is important for today's lesson. We talked about it right at the end of last lesson, but Pythagorean theorem is that the two smaller squares add up to make the bigger square, so the areas. So if we know the areas, okay, we can add the two smaller ones. Now, how do we use the areas of the squares to find the triangle? But if I know the squares, how can I use a square to find the side length of the triangle? What was the final step? So we did it in our calculations a couple of times, look. Put it down here. Square root, isn't it? So 149 was the area of the bigger square. And how do we find the side length of the square? We square root it. Alright? And we did that again with the final one. We did, look. Square root of 261. We found out that the square root of 261 was 16.2. So this was the difference between one like this and the Pythagorean triple, because the Pythagorean triple was all integers, yeah? All whole numbers, whereas most of the ones you're going to be doing will end up having a decimal answer. Alright? So, can I give you one more just quickly to check? Yeah? I'm going to have to probably go over to the computer. So here we go. Doesn't like drawing. So I'm going to give you one.
Wait, I know how I didn't realize this before. But if 360 is a full circle and 90 is half of 180, that means 90 is a quarter.
You are correct, yeah. Alright guys, so let's say this one is 2.5 and this one's 8.6. I want to know x, and I have to tell you that that is a right angle triangle, so we don't. Okay, so even though it's decimals, nothing changes. You've got calculators. Alright? Sienna? Do it and then move it back up. Alright? Even though it's, so you just write the same thing, so write it all out, yeah? If you want to draw squares, that's up to you, but maybe you're developing a different approach, but let's keep it organised and as much working as we can. Alright, let's have a look then. So you're going to give me step by step. So hopefully you've written down Pythagoras, and I would always write it down, it helps you identify. Which one's which? Which one's A, B, C? It doesn't matter. Doesn't matter at all. And X is C. Does A and B matter? No. The only one that actually matters is that, what was this called? Do you remember the name of this side of the triangle? Had a P in it. It's the hypotenuse, wasn't it? And the hypotenuse is always C. Right, that's one thing there. Is the two smaller ones up. So we've got 2.5 squared, and we've got 8.6 squared is equal to x squared. So what's 2.5 squared? 6.25 plus 8.6 squared? 73.96. That will equal x squared. So that's 80.21. Okay, and then how do we find x then? So x is the square root. Why did you do 6.5 squared? Yes, but I did 2.5 squared, which is what you did, which is 6.25. I don't have to square that. I've done the squaring bit. Don't forget what it's about. Why am I squaring? Because I want the area of the square. If I square the area of the square, what am I doing? Nothing. Nothing that makes any sense, right? So try and think, am I doing something that makes sense? Nine, 5, 6, like that. So if you round it, well, if you rounded to the nearest whole number, it would be 8. It would be 9. If you rounded to one decimal place, it would be 9.0. If you rounded to two decimal places, it would be 8.96. It depends. If I said to you, just give me the answer, if you wrote the answer 9 without the unrounded answer, I would probably mark you wrong. So I would always, you with us, Joe? I would always say, if you're going to round your answer, that's perfectly acceptable. And in some questions it says, round your answer to the nearest whole number, or round it to two significant figures, or lots of those things. But if it does say round, or you choose to round, write your number unrounded first to a few decimal places, and then round, because then I know you have. If you make a mistake in rounding, that's not a massive problem. But if you write 9 and you didn't write that it was 8.9, I might kind of go, oh yeah, okay, but maybe you made a mistake. I won't know. So it's good to know you didn't make a mistake. Sorry, Manny, you had your hand up. All right, do you want another one? Rhetorical question. I don't care if you want one, you can get one. Okay. In a question, if it says find y, you're not allowed to say, here it is. That's a common, that's the old joke. Yeah. Here it is, find y. No, you actually have to calculate y. But actually saying that, first step needs to be figure out, okay, so I want to know what the value for y is. Let's see whether I can catch you out.
And then you have to find the square root of that.
Exactly, so we know that a squared plus b squared is equal to c squared. So, Talia, I'm sorry, you changed it. By redrawing it, you swapped y to be this side. The longest side is 15, right? So that is my C. This is my A, and this is my B. So I've actually got 7 squared plus B squared equals
C squared.
Right? So that means to work out this one, because remember, it's like doing 2 smaller squares adding to make the bigger square. The big square is the 225. One of the smaller squares is 49. You're all getting that, but this is the one I want to know. So I have to actually subtract, don't I? So 225 subtract 49 gives me b squared.
I was about to